Imagine Voyager, our tiny metallic emissary sailing through the vast, dark ocean of space. It carries the sights and sounds of Earth, a message in a bottle cast into the cosmic ocean. For nearly 50 years, Voyager has traveled farther than anything we've built, embodying our desire to explore. Attached is a golden record, greetings, music, and images from Earth, a message for any who might find it. Now, as its power fades, Voyager's journey becomes a symbol of hope and human curiosity. The cosmic ocean is vast, but Voyager has shown us we can cross it. The Voyager mission was born from a rare cosmic opportunity, a once-in-176 years alignment of the outer planets. This alignment allowed a single spacecraft to visit Jupiter, Saturn, Uranus, and Neptune, using gravity assists to slingshot from one to the next. The grand tour was planned, but budget cuts scaled it back to two probes, Voyager 1 and Voyager 2. Their primary mission, explore Jupiter and Saturn in detail. Anything beyond was a bonus. Voyager 2 launched first in August 1977. Voyager 1 followed in September on a faster trajectory. Each probe was a marvel of 1970s engineering, equipped with cameras, spectrometers, magnetometers, and instruments to study cosmic rays and plasma waves. Power came from radioisotope thermoelectric generators, RTGs, using the heat from decaying plutonium. The mission's goals: study the weather, magnetic fields, and rings of Jupiter and Saturn, and get close looks at their moons. At the time, our best images were blurry telescope photos. Voyager promised to turn these fuzzy points of light into complex, dynamic worlds. The stage was set for one of the greatest voyages of discovery in human history. The alignment was fleeting, miss it, and the chance would not return for generations. Voyager's launch was a race against time and a leap into the unknown. The mission's success would depend on precision, ingenuity, and a bit of luck. The world watched as humanity reached for the outer planets. Voyager's journey began with a rare window and a bold vision. The grand tour was underway. The adventure had only just begun. The Voyager encounters with the outer planets were spectacular, sending back data and images that changed our view of the solar system forever. At Jupiter, they revealed the Great Red Spot as a massive storm, discovered faint rings, and found active volcanoes on Io. Evidence of a subsurface ocean on Europa hinted at the possibility of life. At Saturn, Voyager studied the rings in detail, discovering thousands of ringlets and mysterious spokes. Titan's thick, nitrogen-rich atmosphere made it a prime target for future missions. Voyager 1's flyby of Titan sent it out of the plane of the planets toward interstellar space. Voyager 2 continued to Uranus, finding a tilted, cold world with new moons, rings, and a bizarre magnetic field. At Neptune, Voyager 2 discovered giant storms, faint rings, and geysers of nitrogen ice erupting from Triton. After Neptune, Voyager 2 was flung southward, joining its twin on a path out of the solar system. The planetary postcard was complete: 4 giant planets, dozens of moons, and a transformed understanding of our cosmic neighborhood. The images became iconic, inspiring generations. The discoveries rewrote textbooks. Voyager turned distant points of light into living worlds. The grand tour was a triumph of exploration. The outer planets were no longer mysteries, they were places. Voyager's legacy was secure. After their planetary encounters, the Voyagers began the interstellar mission, exploring the edge of our solar system. Their new goal: find the boundary where the sun's influence ends and interstellar space begins. For years, the probes traveled through the heliosphere, a vast bubble dominated by the solar wind. In 1990, Voyager 1 turned its camera back for a final portrait, the pale blue dot, showing Earth as a tiny speck in the cosmic dark. After that, the cameras were turned off to save power. The probes measured the solar wind, cosmic rays, and the changing environment as they moved outward. Power dwindled. Engineers made tough choices, turning off instruments and rewriting software across billions of miles. The mission became a test of endurance and ingenuity. The Voyagers pressed on, silent sentinels on a lonely road. Decades passed as they approached the edge of the sun's domain. The journey was long, but the destination was historic. The frontier of interstellar space was near. The first major boundary the Voyagers encountered was the termination shock, where the solar wind abruptly slows. Voyager 1 crossed it in 2004 at 94 astronomical units. Voyager 2 followed in 2007 at 84 AU, revealing our heliosphere is squashed and asymmetrical. Beyond was the heliocete, a turbulent zone where the solar wind meets interstellar pressure. The probes spent years in this chaotic region, sending back surprising data. The ultimate goal: crossed the heliopause, the true edge of the sun's influence. In August 2012, Voyager 1 detected a dramatic drop in solar particles and a spike in cosmic rays. It had entered interstellar space. Voyager 2 crossed the boundary in November 2018, confirming the heliopause is a clear, distinct frontier. Two crossings, in different locations, gave scientists a better understanding of the heliosphere's shape and nature. The Voyagers became our first interstellar explorers. They showed the solar system is a bubble, moving through a vast galactic ocean. The data redefined our place in the galaxy. The boundary was crossed, a new era had begun. Humanity had reached interstellar space. The cosmic shoreline was real. By the early 2020s, the Voyager probes were running on fumes. Their power sources nearly spent, most instruments were shut down, leaving only a few essential ones active. The final transmission was a slow fade, the signal growing weaker as the probes drifted farther from home. The Deep Space Network strained to catch these last whispers, data packets traveling over 22 hours at the speed of light. Voyager 1's final data arrived in early 2025. Voyager 2 fell silent a few months later. The era of Voyager was over. The last transmission wasn't a picture, but a stream of numbers, magnetic field readings, cosmic ray counts, plasma density. This was raw data from more than 160 AU away, a final snapshot of the interstellar environment. For the mission team, it was a bittersweet farewell and a moment of triumph. The probes had far outlived their original mission. Their final data packets were the culmination of a half-century of exploration. Now, the work of analyzing this precious dataset could begin. The last whispers from the void held the key to understanding our galactic neighborhood. Voyager's voice faded, but its discoveries endure. The final Voyager data revealed the true nature of interstellar space. Direct measurements showed the plasma between stars is denser than expected. A thin, electrified gas, not a perfect vacuum. The magnetometer found the interstellar magnetic field was draped around our heliosphere, shaping its boundary. Cosmic ray data confirmed a dramatic increase outside the heliosphere, highlighting how well our solar bubble shields us from radiation. These findings are crucial for planning future missions beyond the sun's protection. Comparing data from both probes, scientists built a 3D map of the heliosphere's edge, a dynamic, shifting frontier. The boundary is not a static wall, but a roiling, active region. Our solar system is not isolated, it interacts constantly with the galaxy. Voyager's final transmissions gave us our first real look at the space between the stars. The interstellar medium is alive with complexity. The legacy of Voyager is immense, far beyond the data it collected. It transformed the outer planets from distant points of light into vibrant, complex worlds. Its images are iconic, inspiring generations and fueling public imagination. Voyager proved long-duration, deep space missions are possible. The gravity assist technique it perfected is now standard for interplanetary travel. Its engineering solutions shaped every probe that followed. Missions like Galileo, Cassini, and New Horizons all stand on Voyager's shoulders. The pale blue dot image gave us a humbling perspective on our place in the cosmos. Voyager reminds us we are all crew members on a tiny spaceship called Earth. Even as their signals fade, the probes travel on, silent ambassadors to the stars. The golden records may one day be the only evidence we ever existed. Voyager is a monument to human curiosity and hope. Its journey is a story of exploration, wonder, and the best of what we can be. As we reflect on Voyager's journey, three insights stand out. First, the space between stars is denser and more dynamic than we imagined, shaping our solar system's bubble. Second, cosmic radiation is intense beyond the heliosphere, confirming the sun's vital protective role. Third, the heliopause is a clear, well-defined frontier, a sharp boundary between the sun's domain and the galaxy. Voyager's final data will guide future interstellar missions, shaping the next generation of explorers. The silence of Voyager marks the end of an era, but its legacy is the foundation for the future. The journey it began is far from over. Voyager's story is about our relentless drive to explore and understand. As we look up at the night sky, we are reminded the cosmic ocean awaits. The next great voyage is just beginning.